Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. Today this is lecture number 5 of the unit electric charges and welds. Today we will discuss about the electric dipole. So let's begin with the electric dipole. Now what is dipole? What we can say is that electric dipole, it is a combination or it is an arrangement of two equal and opposite charges. They are separated by a finite distance. So our basic requirement is two. First, they should be a two charges having the same magnitude. They are the two equal magnitudes, but having an opposite nature. They should be of opposite nature, and they must be separated by a finite distance. So this constructions can form an electric dipole. Now look at this. Here one charge is there, which we say is an minus q. Here another charge is, say, there is a, it's an plus q. Distance between minus q and plus q, that we have mentioned, is it is a 12. And now it we can say it forms an electric dipole. Now let's define one more term. It's a dipole moment that we denote as an p, and it is a vector quantity. What it would be? Dipole moment is magnitude of any one charge, it's an q, multiplied by sep distance between two charges. So this is p is equals to q into 12. As I said, dipole moment is a vector quantity. So this is just a magnitude. P is equals to q into 12. It is a magnitude of one charge multiplied by separation between two charges. It's a q into 12 in this case. But what would be the direction of the dipole moment? Direction of dipole moment is from negative charge. Direction of dipole moment is from negative charge to positive charge. It is a direction of dipole moment. So if I want to see the direction, I should write like this. It's a dipole moment direction. Dimensional formula of the dipole moment, it is m0 l1 t1 I1, because I will replace q is equals to I into t. So is it clear? So let's summarize. What is electric dipole? Then we can say it would be an arrangement of two equal in magnitude but opposite in nature charges, and they are the separated by a finite distance, thus can form an electric dipole. Now what is the dipole moment? We can say it's an p is equals to q into separation between these two charges. It's a q into 12. Scalar quantity or vector quantity, we should say it's a vector quantity. Then what would be the direction? Its direction would be from negative charge to positive charge. Yes. So let's find out electric dipole questions. Let's say this is minus 3q, this is plus 3q, and the separation between these two is the L. Now we have been asked to find out dipole moment and its direction. I have been asked to do so. So first, what I should know is dipole moment. First, I'm interested in magnitude. What I should write? I should write a charge of a positive particle. It's a 3q multiplied by separation between these two charges. It is L. So P is equals to 3q by L. Would it be having an unit? Yes. Unit of charge, it's in coulomb. Unit of length, it's a meter. So I can write it as in coulomb into meter. Now direction. Direction of dipole moment is direction of dipole moment should be from negative charge to positive charge. It should be from negative charge to positive charge. So direction would look like this. This is the dipole. Get it? Any queries? Concern? No? Let's move on quickly. Very next question. Let's say they have given a certain arrangement like this, that this is minus 2q, this is plus q, this is plus q. The angle between these two is the 60 degree. The separation between these two is the a. Again here the separation is a. And they have asked that find out net electrical dipole moment. P net is required. Now, before going to P net dipole moment or net electrical dipole moment, first tell me, does this construction forms a dipole? Because when we define the dipole, we say it would be of combination of two charges. Here three charges are there. Another thing what we have thought is both the charges should be of same magnitude. Here it is a one is minus 2q and other two are the plus q, and they have been separated by a finite distance. So in this kind of questions, what I need to do is I need to rearrange the diagram such that it can form a dipole. So what I can do is I can split this minus 2q such that it can form a dipole. How could I done this? Let's look. If I break minus 2q into minus q, then plus q is here, and one more minus q at this position. This is minus q, and this plus q was already there. So now look at the diagram, new arrangement very carefully. Look at this. Can I say this is my first dipole and this is my second dipole? So first dipole is there, second dipole is there. What would be the dipole moment of first dipole? What I can write is it's a q multiplied by a. Magnitude of second dipole p2, it is again q into a, and both are having an angle of 60 degree. Let's find out the directions of both the dipole. Let's find out the directions. Here it is minus q, here it is plus q. So this is p1. Here it is minus q, here it is plus q. So this is p2. And both this having an angle of 60 degree, as well as both this are having a same magnitude. Both this are having a same magnitude. So what I can write is p net is equals to 2p cos theta by 2. So I should write as 2 multiplied by p multiplied by cos 60 by 2. It's a cos 30, and cos 30 give me a root 3 by 2. So this 2 would be a cancel, and final answer should be root 3 multiplied by q multiplied by a. Yes, did you understand this? Correct. Let's do one more question having the same principle. Let's say they have given like this. This is minus 2q, this is plus 3q, and here they have been given minus q. here they have given is that this angle, let's say this separation is a, this separation is a, and this perpendicular length is a, and they asked us to find out net electric dipole moment. They require to find out the net electric dipole moment. Now what you should do, first tell me whether this construction forms a dipole or not. Yes, you are thinking absolutely correct. You need to rearrange this to behave this construction as a dipole. Now how should I rearrange this? Let's check. This is minus 2q. So to form a dipole, this 3q should be break into plus 2q and q. Here it's a plus, sorry, it's a minus q, and here it would be a plus q. This separation is 2a. This separation is 2a. They have given that this is a. This is a, absolutely yes. Even this is a. So separation between this two. Separation between this two is the root of 2a according to the Pythagoras. Yes. Now let's look at the magnitude of each one. Let's give a number. This is first dipole. This is second dipole. Magnitude of first dipole, it would be a 2q multiplied by 2a. So this is equals to 4 into q into a. And magnitude of second dipole, it is q multiplied by root of 2a. Yes. Now let's find out the direction of first dipole from negative to positive. This is p1, and direction look like this. Yes. And direction of second dipole, it would look like this. It's a p2. So what I can write like is, this is p2. Now what would be the angle? Look at this. This is a, this is a. This should be a 45 degree. This should be a 45 degree. So whatever the remaining section, this would be a 45. So this would be 45. So this complete makes 135 degree. This completes make 135 degree. Now what you need to do is you need to find out p net. But look at this. This is bit complicated as both are having a different magnitude. So what you need to do is you need to find out magnitude like this. It's an p1 square plus p2 square plus 2 p1 p2 cos theta. While theta you are going to put, or theta you are going to put a value of 135 degree, and you might know that value of a cos 35 is equals to cos of 45 degree, but having a negative sign. Yes. So put up the value and solve this. But is it possible? Will you do it? Okay, I left it for you and you will do this. Okay. So we know now that how numericals of an electric dipole can be done, and what could be the situations if I want to calculate, what could be the situation if I need to calculate the electric dipole moment. I can just rearrange it and the things will be done. Now let's say electric field due to electric dipole. we have an electric dipole, and I need to just calculate the electric field due to this dipole. So basically we have primarily we have two arrangements. In a first arrangement, a situation would be look like this. This is minus q, this is plus q. The separation the separation between these two charges is, let's say, 2a. This is midpoint of this. From here, at a distance r, let's say at this position, which is at an r separation, I need to find out electric dipole. So this position is known as the axial position of an electric dipole. This is what we call as an, this is electric dipole, axial position of an electric dipole. It is, we can say, it is on the axis of a dipole. And the second situation would be look like this. Let's have a look. It's a minus q here, it's a plus q here. Let's say separation is 2a, and you required an electric field at this point p. This perpendicular distance can be considered as an r. This is what we call as an equatorial position of an electric dipole. So basically what we are going to discuss is, we are going to discuss about, basically on a primary note, about this two positions. One is the axial position and another is the equatorial position, and we will next we will go to the applications of these two positions. It's an electric field due to dipole at any point p. So first let's look at the electric field due to this two, and let's move to the next slide. First we will go with the axial position. What the situation would be, this is minus q, this is plus q, their separation is 2a, it's a midpoint, this is point p, and this is distance r. So simply what you need to do is, you need to find out the electric field at this position. Now how could I find it? Let's do it very quickly. This is charge number 1, this is charge number 2. What you need to do is, you need to just write it down. Magnitude of electric field due to both the charges. What would be the E1? Tell me. What is the master formula for a point charge? It is K multiplied by Q divided by square of the distance. So here it is K multiplied by Q divided by what would be the separation? Here it is P. So this separation is R, and it is a 2a, it's a midpoint, so this separation is A. So I should write it as an R plus A whole square. This is E1. Now what would be the E2? I should write it as, here it is a plus Q, so this separation is R minus A. This is K multiplied by Q divided by R minus A whole square. Now we have done up to the magnitude. Now next stage is of direction. Yes, you are thinking it absolutely correct. So what would be the direction? Look at this. This is plus q. When we need to find out the direction, we just put up a taste charge, and taste charge is always positive. So this plus q will repel it. This plus q will repel it. So this E2 would be in this direction, and this E1 would be in this direction. Can you get it? Yes. Now which one would be a larger in magnitude? Look at this. Here it is R plus A whole square. Here it is R minus A whole square. So by observation you can see this, that when we need to find out the E net, when we calculate the E net, E2 would be higher and E1 would be the lesser. So E net should be is equals to E2 minus of E1. Yes, if I if I am going to solve this, if I am going to solve this, what I will be having is, it is a 2 multiplied by P into R divided by 4 pi epsilon naught, which we say K is equals to 1 upon 4 pi epsilon naught into R square minus of A square whole square. You can do this calculation. So this is what we get is E net is equals to 2 into P into R upon 4 pi epsilon naught into R square minus A square whole square. Now, one very interesting case is, if we considered one for very interesting case, if I can consider, if let's say if R is much greater than A, if R is much greater than A, then I can write like this: E is equals to 2, here 1 upon 4 pi epsilon naught, it's in K, it is P, here it is R is there, here R square square, so this is R cube. So this E net is equals to 2 kp, it's in magnitude obvious. So E net, this is equals to 2 kp by R cube, this is the magnitude. So we can simply write it as E directly proportional to the 1 by R cube of, if other things are remain the constant. So this is axial position. If I have been given this R much greater than A, this is what we considered as a short dipole. Please do remember, either they will say that distance where you need to find out the electric field is much bigger as compared to the separation between two dipoles, or they will say that consider a short dipole. So if they have been asked that consider a short dipole, I can directly use this relation E is equals to 2 kp by R cube. Now one very important term, that is direction of E net. As E2 is bigger, E1 is smaller, so direction of E net, this is in this direction, E net. Yes. One more thing, direction of dipole moment, this is minus q, this is plus q, so this is direction of P. Yes, everything is clear. So what I have done is, I need to find out the electric field at the axial position. I have taken one dipole, minus q plus q, and I just find it out the magnitude of electric field due to each dipole. It's in kq by r plus a whole square and kq by r minus a whole square. Then I find out the directions. I find out the directions, and I observe that both are in the opposite direction, so just I subtract it. When I subtract it, I found this. And if I consider a short dipole, that is if r is much greater than a, then I will have an E net is equals to 2 kp by r cube. Got it? Okay. Now let's quickly move to the next position. It's an equatorial position. Electric field due to electric dipole at equatorial position. A situation would be look like this. This is minus q, this is plus q. This separation is 2a. This point, this is P. This distance is r. Now look at this. You need to find out. This would be the A. Again, this would be the A. Let's give them a number. This is charge 1. This is charge 2. Now first, electric field due to charge 1, what would be? It's an K multiplied by Q divided by, what is the distance? Look at this. This is R. This is A. According to the Pythagoras, this is the hypotenuse and it should be under root of R square plus A square. I need to square this. I need to square this. So it would be an k cube by r square plus a square, because my standard formula is k cube by r square and my r is under root of r square plus a square. Yes. Now let's find out the electric field due to second charge. This is E2. What it would be? What it would be? Now find, if I find out the E2, it would be an k multiplied by q divided by, again the separation will look like this. This is again under root of r square plus a square. So this is k cube by r square plus a square. Now let's move quickly for the direction of this. How could I find out the directions? Look at this. Here I need to put a test charge. It is a positive. This is minus q. This is q naught. So this will move in this direction. This is electric field due to first charge. Here it is plus q. Here it is plus q. So this will move in this direction. This is E2. So our situation is something like this. This is the E2. This is the E1. So E net would be in this direction. E net would be in this direction. So if I apply a mathematics, what I could have is, E net should be is equals to, it is a k into p divided by r square plus a square to the power 3 by 2. It's a E net is equals to k into p divided by r square plus a square to the power 3 by 2. If I considered a special case, that is if r is much greater than a, then I can find it out that E net would be is equals to k p by r cube by magnitude. I should say it's by magnitude. And same way here I can write like this, E directly proportional to the 1 by r cube. Okay, now let's check it out the directions. This is minus q, this is plus q. This is the direction of electric dipole moment p, and this is the direction of E net. Yes. So can we summarize these two positions? First, now very first, it is an axial position, something like this, minus q plus q. At this point you require a electric field. Let us consider this. As a short dipole. Let us consider this as a short dipole. Then what you know is electric field, it is a 2 kp by r cube. Direction of dipole moment in this direction. Even direction of electric field is in this direction. So this is angle between P and E is 0 degree. Now let's move to the second position. It is equatorial position. Situation look like this. This is minus q plus q. This is point P. Here the separation is r. So let's say we are considering a short dipole. Electric field would be equals to kp by r cube. This is direction of P, and this should be the direction of E net. So this is direction of P, this is the direction of E. So if I write angle between these two, angle between dipole moment P and electric field E is 180 degree. It's a pi. Yes, this magnitude is kp by r cube and this magnitude is 2 kp by r cube. Yes, everything is clear. So can we move to the numericals? Of this? Let's find it out. Let's say I have been given that question, that this is dipole. Let's say this is minus q, this is q, and their separation is a. This is midpoint. They have given this location, that this distance is r, and this location is p. They have given a different location. That location they have given a name as in q. Again, this separation is r. They have tell us that r is much greater than a, so indirectly they instruct us to consider a short dipole. Now they ask us that electric field at location 1 is E1, and electric field at location q, it is an E2. They just ask us that find out first E1 is to E2, second E1 is to E2. Now do this very carefully. Can you find out the difference between two questions? Yes, first one is the scalar ratio, another one is the vector ratio. So let's say first write it down, the electric field at location 1. Which position it is? Which position? Is it which position? Yes, correct. It is an axial position. What would be the electric field due to axial position due to electric dipole? It would be a 2 kp by r cube. It's an electric field due to first. Electric field due to 2. This is minus q, this is plus q. This is perpendicular point. Perpendicular point, what we say, it's an equatorial position. So at equatorial position, what would be the value? It's a kp by r cube. Now I need to find out E1 is to E2. So if I take a ratio of this E1 is to E2, I will easily get it's a 2 is to 1. It's a 2 is to 1. This is the first question. This is the question number 1 that I have solved it. Now what is the question number 2? It's an E1 is to E2. I know that. I know that direction of at equatorial position, direction at equatorial position would be same as the direction of dipole moment. So if I mark a directions here, this is direction of dipole moment. So direction of E net would be in this direction, while I talking about the E1, while direction of E2 would be in this direction. It's an opposite to the dipole moment P. So I should write like this: E1 is to E2 should be is equals to minus 1, because both are in opposite directions. Because both are in opposite directions. Yes, can you get it? Okay, shall I add one more question to this? If they asked that E1 dot E2 is greater than 0 or less than 0, think. They have been asked that E1 dot E2, is it greater than 0 or it is a less than 0? That I need to find out. E1 dot E2. Now first tell me, what is the angle between E1 and E2? When I make a dot product, I should look like this. It's an E1 E2 cos theta. It's an E1 E2 cos theta. Here theta is, look at this, direction of E1 in positive x, direction of E2 in negative x. So this theta is equals to 180, and when theta is 180, cos 180 is minus 1. So this E1 dot E2 should be less than 0. So am I clear with this? Am I clear with this? Yes, everything is okay. Yes, can you do this? Shall we move to the next question? Shall we? Shall we move to the next? Okay, so let's look at the next question very quickly. You need to solve this on your own, so start doing it. Let's say I have been given this. I have been given one dipole having a dipole moment p, and this is another dipole that has been placed p. Even this is having the same dipole moment, it's a p. Both are the short dipole, both are the short dipole. You need to find out electric field at this location. Let's give it a number as this distance is r, and you need to find out the electric field. Need to find out electric field at location A. Both dipoles are short dipole. How should we do this? Think. Can you do this? What is to be done? What is to be done? First, let us check it out. That what are the electric fields? So let's give these a number. This is the first dipole, and this dipole is second. So we are having a two dipoles, 1 and 2. I need to find out electric field due to first dipole first. Now tell me that this for this dipole, for first dipole, this point is at an equatorial position. Oh, sorry. Uh, it is at an axial position. Sorry, my mistake. For first dipole, point A, it is at axial position. So when it is at axial position, I need to write like this. It is 2kp by r cube. And direction of this is the direction of dipole moment p. So it would be in the same direction. This is even. And for second dipole, this point p, for this point p, it is at an equatorial position. So magnitude of it is kp by r cube. Now direction of electric field, this is the direction of dipole moment in the positive y direction. So direction of electric field would be reverse of this is E2. This two, this two are having an angle of 90 degree. This two are having an angle of 90 degree. So for E net, for E net, I need to calculate like this: E1 square plus E2 square. It's in plus 2 E1 E2 cos theta, but cos theta is 90, so that terms has been vanished. So the remaining part would be only the E net would be equals to under root of E1 square plus E2 square. Yes. So if I solve this, I can write like this. It's an 2kp by r cube whole square plus kp by r cube whole square. This is equals to root 5 kp by r cube. This is E net. Got it? This seems interesting. Yes? No? Okay. Let's move to the next. Electric field due to electric dipole. This is we need to find out at any point P. This is I need to find out at any point P. So situation. So the situation would be something like this. Let's say this is minus q, this is plus q, and this is true for the short dipole only. This is valid for short dipole only. let's say you require an electric field at this location. Suppose this is 2a. At this point, and this separation is r. This angle is theta. This angle is theta. So what you can do is, let's look at this very carefully. Let's look at this. This is p. Yes, dipole moment. So I can write like this. This is p cos theta. Yes, are you get it? Yes. And this would be the p sine theta. Yes. So if I have been asked that these are the two dipoles, one is the p cos theta and another is the p sine theta, can I consider it like this? Yes, absolutely. So if I say electric field due to dipole 1, which is a p cos theta, what it would be? So I can say that it is a 2kp dash, I should write, divide by r cube. It is at an axial position, and as a p dash I need to write a p cos theta, so this is 2kp cos theta divided by r cube. Second, for a p sine theta, dipole, this is at an equatorial position. So what I can write is E2 is equals to 2kp dash by r cube. Here p dash is p sine theta, so this is 2kp sine theta divide, sorry, it's an kp sine theta. It's an kp sine theta divide by r cube. Yes. Now you have won half of the battle. Only the remaining thing would be the direction. How will you get it? How will you get it? So what you can do is find out the directions. It's an p cos theta dipole. This is a dipole, a p cos theta. So an electric field is at axial position. So for axial position, angle between dipole moment p and and electric field is 0 degree. So this is the E1, and here the dipole moment is in this direction. So you need to find out electric field at this position. So again, this is an angle theta. Can you look at this? This is an angle theta. So you can have an E net, which is root of E1 square plus E2 square. This E net would be equals to root of E1 square plus E2 square. So while you will put up a value and solve this, you find that it is kp by r cube under root of 1 plus 3 cos square theta. It would look like something this. It would E is net is equals to kp by r cube multiplied by under root of 1 plus 3 cos square theta. Yes, just remember this E net. You should remember this. One more very important thing, this is valid for short dipole only. This is not valid for a normal dipole, because we have directly applied a 2 kp by r cube, and this relation 2 kp by r cube or a kp by r cube, 2 kp by r cube or a kp by r cube, this is only valid when dipole is given as a short dipole. If dipole is not a short dipole, we cannot write like this. Got it? Okay, let's move to the numerical of this. Let's say this is short dipole, minus q plus q, and a location is here. This is, let's say, r. This distance is r, and this theta is 60 degree. You need to find out electric field. You need to find out electric field at you need to find out electric field at point P. So what I can write is E should be is equals to Kp by R cube under root of 1 plus 3 cos square theta. So that should be Kp by R cube under root of 1 plus 3 into cos 60. Cos 60 is half. Its square would be 1 by 4. So if I solve this, it is a Kp by R cube multiplied by, this is 3 by 4. 4 plus 3, this is root of 7 by 4. If you wish, you can take 2 at 2 and then out of the square root. So it would be a Kp by 2R cube multiplied by root of 7. This is E net, Newton per coulomb. This is the direction of electric, this is the unit of electric field. Yes, can you do it? Okay, great. So let's summarize this what we have done up till now. We have started with the electric dipole. Then we have find it out that what could be the electric field due to a dipole. What could be the electric field due to a dipole? We have gone through basically two cases, and one is their application. So first two cases were electric field at an axial position, electric field at an equatorial position. We have find out their electric field value and their direction with the dipole moments, and then at last we have derive a relation for electric field at any point P. Yes, I hope these things are clear. Request you to do as many questions as possible, because these are the basics. Because when we move to the unit number 5 of class 12, it's in magnetism and matter. Whatever we are discussing here, as compared to the electric charge, at that point of time we are going to discuss about the magnetic charges. So we are going to copy paste these things over there only. So this is basic and this is required at when we are going to discuss this magnetic charges. So these are the basics. Do it very carefully. Practice more number of questions. When you practice it, you will get the doubts, clear that doubts, and things would happen in positive manner in physics as well. So let's sign out here. Take care. Goodbye.